All right. Good morning, afternoon, everybody. Welcome to our webinar on China's EV safety and the immersion cooling technology. My name is Zishan Kadri. I will be your moderator and one of the speakers today. I will guide you through some of the first segments of presentation today. Just give me a second here. I also have my fellow colleagues here, Arno Durantes. He's the president of GICA. We have Marco is an expert in EV technologies. We also have Cecile Para. Cecile Para is also expert in EV technologies. She's also an influencer on LinkedIn here. So all four of us will be presenting to you today's webinar. As you can see, I'll just share the agenda with you, and then I'll go into some sort of market analysis, and then I'll pass it on to Cecile, Arno, and Marco here. So as far as today's agenda is concerned, the first thing we're going to present to you will be some market analysis on immersion cooling technology, which will be followed by some highlights on ultra-fast charging and its consequences. We'll present to you an overview of China's new safety standards, followed by immersion cooling technologies, and Arno will be presenting some testing and validation that has been done at ExoS and the impact on the battery chemistry. And then we'll discuss the expectations for Europe and North America as well. Now, before I get into the market analysis, for those of you who are new to Global Immersion Cooling Association, I would just like to give you a bit of a highlight as to what we do and how this organization was created. So last year, ExoS, Karar, and Lightens, three companies came together to create this association. And the aim of this association is to advance the widespread adoption of immersion cooling technology and to provide a platform where OEM suppliers, manufacturers, policymakers can come together and discuss the advancement of the technology. So far this year, we have taken a few initiatives, provided some services as well. Three of them, which are quite important that I would like to highlight here, is we've been helping in advancing the research and standards when it comes to immersion cooling technology in collaboration with ISO, SAE, and DIN standards. We're also educating our members by doing webinars such as these ones, providing white papers, providing market insights, and at the same time advocating towards the adoption of immersion cooling technology within the EV sector, data centers, and other industries. We also aim to provide a platform where OEMs, tier one, tier two suppliers, academic institutions, and policymakers could come together and network with each other and discuss the future of immersion cooling technology. Moving on to our members here. So the three founding members are Karar, ExoS, and Lightens. And we've been honored to welcome new members within our associations within this year. They are APL, Cortex, ATA, Moltex, BP, NOAA, Shell, which recently joined, Philips, and Inventec. So welcome to all these members and the new members that we're going to receive in the future. Now, I'll just move on to a little bit of market analysis here. So we often get this question as to how immersion cooling technology is growing into different sectors and in different regions. So the three main regions, as you can see, China, North America, and Europe. We just want to give you a snapshot as to how immersion cooling is growing here. So as you can see, there is an impressive growth when it comes to data centers in all three regions, China, North America, and Europe. In China, you can see just in 5-6 years, it's going to grow from less than $20 million to more than $150 million. At the same time, there is a significant growth in the EVs and AI as well. AI is also gaining momentum like data centers. And you can see that in North America and Europe as well, that AI is growing very fast along with data centers. The EV growth is a bit moderate when it comes to North America and Europe, but that's not surprising given the fact that the EV adoption has slowed down in both the regions, while China is still going full speed ahead. However, we are expecting that as more and more infrastructure is available on the EV side, there will be more EV adoption, and we're going to see a widespread adoption of immersion cooling technologies in the EV sector as well in North America and Europe. Now, moving on to China, where our focus is during this webinar. In order to set the stage, I just want to share with you how dominant China is when it comes to the battery industry. Last year in 2024, they dominated um, by about having 75% share of lithium production batteries. As you can see here, CATL has about 38% of market share, followed by BYD, 18%, both Chinese companies. There are other Chinese companies as well, such as Kelp, Goshen, Eve Energy, and Sunwon. The only other country which has some sort of a significant presence beside China is South Korea with LG and SK. However, China still dominates, and they will continue to dominate. If you happen to be in IAA recently, you might have seen how Chinese presented their battery technology, especially CATL. It was very, very impressive. Now, we believe with this new safety standards that China is going to implement next year is going to have an impact on the battery technology, and it will also lead towards the wider adoption of immersion cooling technology. And Cecile, Arno, and Marco are going to present that in more detail. Before I pass it on to Cecile, I would like to welcome everybody to share your question throughout the presentation. The Q&A session is open. Towards the end of this session, we're going to have your questions presented to the speakers, and we'll try to answer as much as we can. With that, I'll move on to this slide, and I'll pass it over to Cecile.
Thanks, Hisham. So we have seen in this introduction the dominance of China, and in China there are two main strains at the moment. So one is ultra-fast charger, and the second one is about this new safety that we are going to talk about in this presentation. So I was recently in Auto Shanghai, and one of the main trains presented here was about fast charging, and when I say fast charging, I mean ultra-fast charging. So several car manufacturers and suppliers are already proposing super ultra-fast chargers and also cars that allow to get this ultra-fast charger. When I say this, I mean megawatts, so from 1 megawatt to 1.5 megawatt chargers for passenger cars, not for commercial trucks, but for passenger cars. Among these technology, we can already mention Huawei that get a 1.5 megawatt charger. We have car manufacturers such as Zeekr or BYD. We will detail that a little bit later. And also CATL is about to do 520 kilometers of recharge in 5 minutes, so ultra-fast charger. So next slide. So when we talk about ultra-fast charger, we are introducing new challenges for pack design, because this is one of the most stressful conditions for the battery pack. When you drive on the motorway, your cells are not really stressed. But as you move to fast charging and ultra-fast charging, you have a huge amount of heat to remove from your cell. And we are pretty close to the amount of heat we have to remove from internal combustion engine. You can argue that we have been able to remove this heat from internal combustion engine since ages without too much trouble. But the fact is that in internal combustion engine, you have a huge difference of temperature between what you try to cool and the fluid, the coolant, so the water jacket or the lubricant. You have at least 200 degrees Celsius. Plus the fact that the coolant, so the water glycol or the lubricant, get also a huge difference of temperature about, let's say, 80 degrees Celsius, always positive because the ambient air will never go above the temperature of the coolant. And because you have a huge surface to exchange plus a delta of temperature which is pretty big, it is very easy to remove away this temperature. While when you are in a battery pack, you have the cells that are in volume, and also the temperature of the cell you are trying to cool down are pretty much the same than the temperature outside, if not sometimes lower. So sometimes if you are in a very hot summer, the outside temperature can be even higher than the battery cells you are trying to keep cool. So in order to do this, you will have to create a relatively very complicated thermal management for the full vehicle. And this will introduce new components. And it enables new technology, of course. But one example, I put the picture here, is from Valeo, because it's introduced, for example, a lot of problems on how to get fresh air entering the car. Because the problem is that when you fast charge, your car does not move, it's parked by definition. So you have to get a lot of fresh air entering the car, so the fan will run and will make a lot of noise, which is not very convenient for the customers. So all of this puts new trends in terms of vehicle design. Next slide, please. So now if we move on to what it means for the cells, it's very stressful because you have to remove very quickly a huge amount of temperature. So now the objective of this slide is to first see the two philosophies we can get when we try to move away the heat from a cell. So for the sake of explanation, I put here a cylindrical cell, but what I'm saying here is valid, of course, for a prismatic cell or a pouch cell. You have two philosophies to remove the heat. The first one, on the left, says that the heat is going to move parallel to the foil and preferentially through the tab. This is what you are trying to achieve when you use cooling plates that are either on the bottom or the top or both of the cells. Another possibility is to say, I don't care about this preferential path, and I think it will go through the side, and I try to maximize the surface of exchange. Because the bigger the surface of exchange I can have, the bigger I can remove the heat. This is the philosophy you will get, for example, in a Tesla, where you have the serpentine between the cells. But it is also what CATL is doing in the chilling, for example, by putting cooling plates in between the prismatic cell. So the next slide. The advantage is that when you do immersion cooling, you can do both at the same time. You do not have to choose or to see how it's going to happen. Of course, the preferential path of the heat will depend on many things. It will depend on the cell chemistry, it will depend on the cell format, it will depend on the difference of size, so the height, the thickness, etc. But when you do immersion cooling, you have the advantage that you can do at the same time perpendicularly to the foil, but also through the tab. Plus, you can also get the bus bar, and you can also get the electronic, and so on. I put several examples here. So bottom left is one commercially available. I put some quote here because it's on a hypercar, it's on a Koenigsegg. So this battery pack was developed by Rimac and is immersion cooled. On the bottom right, I put a picture I took in Auto Shanghai from, it's either a module, either a small battery pack, also immersion cooled with cylindrical cell. And all of these make a lot of development in the industry through simulation or through testing. So on the top left corner, I put an example of some bubbles, which are the technology used by Carrara. I just want to insist here that immersion cooling is not a technology, a single technology, but immersion cooling is an umbrella for a family of technologies in plural, because there are different ways to do immersion cooling, and it's important to understand this. That's why we have different people here talking about their different solutions, and some can be adapted and so on. So it's important to see that we have different kind of immersion coolings. So next slide. So about
okay, maybe Cecile, let me take over this on the slide, because
okay.
it's I think it's just a consideration based on what you said, and that, or exactly what you were mentioning before, is that ultra-fast charging is in pushing complexity to the next level. As Cecile was mentioning now, the handling of the thermal fluxes within the battery for ultra-fast charging is becoming a paramount importance. And you can see this. I know this is just an example. Not just we'll just interrupt you for a little bit, but looking at the new BYD Super E platform, you already see that the complexity and the sophistication of the thermal management system has increased dramatically. Now we have two cooling plates. In that case, BYD is also using non-conductive refrigerant as medium, and probably for safety and also for durability or lifetime is now going with an LFP chemistry. And this is coming already from the requirement of ultra-fast charging, which is a must for all car makers. Now, on top of that, and this is what Cecile is going to show you in the next slide, we have the safety requirements, which will again cause for the sophistication and the complexity of the thermal management to go to a further next level to comply with the new Chinese regulation. So please go ahead, Cecile. Thanks.
Thanks, Marco.
Or if you want to add anything.
Add one thing on this slide, on the previous slide, please note that it is LFP, but able to charge at C rate 10, so 10C, which is super high for LFP, surprisingly. So we now move on to this Chinese new standard. So when you read this new standard, it will bring you through different pages. So it's pretty long. I'm not going to discuss all of this, obviously, because it will be a full day of webinar if we would do that. I just want to highlight the things that are important for us in terms of safety and battery design and what it can change for the thermal management and immersion cooling. So we have been used to the fact that Chinese already asked to get 5-minute warning before hazardous events, but we are now moving forward. So we want to get more than 5 minutes. Plus, we have to get no fire and explosion for 2 hours, which is pretty long because previously one technique could be to get this warning and postpone as much as possible the runaway. But with this regulation of no fire, no explosion for 2 hours, you have to be very careful. The second one is a thermal propagation. So when you trigger on purpose a runaway or a failure on a cell, you need to make sure that the neighboring cells and module stay runaway free absolutely with no explosion for 5 minutes. So these also drive the usage of some technology like aerogel or mica or maybe some foam in between the cell in order to isolate one problem to the neighboring cells. But don't forget that sometimes this thermal propagation can also be driven through other scenarios, like, for example, rebounding on the leads. And this is an advantage for immersion cooling because in this case, because the cells are encapsulated, if I can say that, in the fluid, you are able to remove different scenarios of thermal propagation, which is quite interesting. Next slide, please. So, we have already talked about that, about the fast charging, but because of the obsession of the Chinese for fast charging, there are also new mandatory tests for after fast charging. So they ask for short circuit safety after 300 fast charging. So 300 fast charges is pretty a lot because it's equivalent to refuel your car, let's say 300 times. And in my case, I refuel my car, let's say maximum twice a month. So in my case, this would be more than 10 years of refueling, equivalent refueling my car. But keep in mind, of course, that your electric vehicle normally is made to recharge not only on ultra-fast charger, but also very often on a home charger, so pretty low charging. So 300 fast charges is really a lot. But after you have stressed the battery several times like that, you need to make sure you have no safety issue with short circuit. Next slide, please. We have also another test in which you are on purpose stopping the cooling to run properly. So you are emulating cooling failure. It can be very challenging for some case, but it's again an enabler for immersion cooling, because once you stop the cooling to run normally, the immersion cooling still stay around, so it still protects yourself for a certain amount of time. So for us, it's still beneficial, I would say, compared to other system of cooling. And the last point is about the smoke emissions. So now we have new regulations that smoke must not enter the passenger cabin for at least 5 minutes post-warning. We get used to the fact that the hot gases must go away the battery pack, but now we also make sure that no smoke can go through that. So we see again here the emergence of new technologies. So I have seen people using membrane. I have seen people trying to use filters. I have seen people using venting that captures the smoke and so on. So it drives new technology and new pack design. Next slide, please. So in all of this, in addition of these two major trends, we have two other things to add. The fact that we see more and more cell-to-pack plus cell-to-chassis. So we start to see them happening commercially already available. And in IAA in Munich last week, CATL was again displaying one of their solutions for cell-to-chassis. And this will also drive new way to design the things and maybe enable immersion cooling. So if we go to the next slide, which I think is my last one, what do we know about this regulation? So we know that CATL already says that all their portfolio is able to pass this new regulation. When you see the battery pack, so the shielding, it was presented in Auto Shanghai. I had the deep look, but also again at IAA last week. In some sense, it looks very clean and I would say nearly simple, but as always, the devil are in the details. So we see some intriguing technologies. The fact that, for example, the channel in between the cells are able to change size thanks to some spring, which means that the thickness in between the cell can change a little bit. So that, again, will drive many things from an engineering point of view, like, for example, the volume of coolant in the system is not constant, so you have to get some bypass in order to adjust that, for example. It is also interesting to see that they use the cell on the other side, so they are, they say inverse, so flip. They have a smart system to remove the gases through a channel, but they also, thanks to this cooling plate in between the prismatic cell, it allows them also to cool down the tabs and also the bus bar, because they are closer to remove some of the heat. Something surprising also is that this chilling, for example, in the Zeekr, so this is the same base, they can use NMC, which means that it's still not the end for NMC. It still gets some possibility, but we see, as my last conclusion here, is that NMC and LFP tend to converge to each other in the sense that LFP now get really fast charging and increase the range really a lot. And NMC also is a little bit safer now with some new features. So this difference between NMC and LFP depends on how you construct your pack, the price you want to put, budget constraint, range, and so on. But with new regulation in China, it makes the battery design, as always, even more complicated. And that's my last slide, if I'm correct.
Maybe if I can add on that, thanks, Cecile. I think you can all appreciate how the level of complexity and sophistication of the thermal management has increased again. Again, here you can see, as Cecile was mentioning, now the cooling channel between the cells, taking advantage of a larger surface to enhance the heat transfer when it's needed. But at the same time, you see smaller cells, you see aerogel separating them, which is a clear intention to control the propagation, of course. So there's the design of the thermal management is selectively picking the path for thermal management, cooling, and isolation, thermal insulation. So, or again, with respect of what Cecile mentioned before, controlling the smoke emissions with cell venting downwards. So the overall conclusion of this first part of the presentation is that the thermal management of the next generation, or actually current generation cars, has dramatically increased, and the complexity has increased. And compared to that, immersion cooling could even be a simpler solution, a more straightforward solution to achieve maybe better, even better results in terms of temperature control and safety. And just for you, or to refresh your knowledge about thermal management, I will go to the next slide, Zishan, please. You see here already, it's not only the technology is just very basic sketches, but also the industrial landscape, which is rapidly developing around immersion cooling solutions. So starting from left to right, you see the typical full immersion, and which is already state of the art, in particular for data centers, as Zishan was mentioning at the beginning of this presentation, but also is expanding into automotive and other sectors, as shown by application from John Deere, Chrysler, or even recently, it was just last month that A123 presented BSS solution with immersion cooling again. So there's a lot of movement, there's a lot of activities in the area, and is already not, I wouldn't say a fully developed market, but is growing very rapidly. And that's why also big players, also JICA members like BP or Shell are interested, because also the development of refrigerants and specialty fluids supporting the immersion cooling solutions is a key aspect of that. So this is not only the only approach. There are slightly different approaches, as you can see what Valeo is doing. They focus on a spray jet cooling, and in addition to the full immersion of the battery. And also what is already being used in data centers again is the two-phase. So where the refrigerant changes phase in order to extract the heat more efficiently. This is already a solution used in data centers by Zutacor or Chemours or NOAA. And is a solution Cara is developing for other markets like automotive, but also marine applications, which are following quickly into this market development. Now we would like to show you some of the activities which are there. I will leave the word to Arnaud, who can talk a little bit about the experience which is being generated in that area on the bench by JICA members. All the different members are running activities and testing of immersion cooling solutions. So please, Arnaud, it's your word now.
Thanks a lot, Marco. Yes, indeed. And we can add on the previous slide that power electronics also could be cooled with immersion cooling, that e-motors could be cooled with dielectric liquid. So the variety of components that can be cooled with immersion cooling or dielectric fluids is really wide. So here you have an example of tests that we performed, the company XOS, which I am CEO of, and the company BP. Thanks a lot for them to accept to share these results. This is kind of tests that we perform together with large NMC cells, which is important here because you know that the cells are becoming larger and larger with higher nickel contents if they are NMC cells. And so to trigger or to reach a non-propagation is harder and harder due to the huge energy contents in these recent cells, battery cells. So here you have an example of a module with 12 NMC prismatic cells. The way the cells was abused was with nail penetration. So you have it at the back of the image, a nail that is puncturing a cell. And you will see a video afterwards, but just before we go to the video, you have a graphic on the right of the slide, which shows two things. In blue, you have sensors, thermocouple sensors that were on the punctured cells, on the abused cells. And you see naturally it reached a higher temperature. But what is more interesting is that the adjacent cell never reached more than 100 degrees just after the cell sees the initial reaction from the punctured cells. Right after, it goes down to less than 100 degrees Celsius. And you can see that after 8 or 9 minutes, 500 seconds, it is far below 100 degrees Celsius. And you know that, or maybe you will discover it, but the new Chinese regulation impose also a maximum temperature of 60 degrees Celsius after the 2 hours after an event occurred. So that's why immersion cooling is such a good candidate, because it was already mentioned, it brings here safety, and it is also very useful for ultra-fast charging. It brings both. Naturally here, I'm only showing results on safety, but I should have also been in a position to share results on ultra-fast charging, where it brings a lot of value. So maybe we can switch to the video, hoping that this will work. Zishan, I let you move to the video. So thanks again to BP and Objects.
Okay, I'm gonna play the video. Let me know when you want me to stop it.
Yes. So you will see that temperature will increase. So you have the temperature on the left, and you see some smokes at the exhaust of the battery module, but no more than smoke. And you see with the thermal camera that the temperature is well stabilized after the cell has been punctured, which means that you have no thermal runaway propagation to the other cells, because naturally if you have propagation, temperature is really higher than that. So let's stay a bit more here. You will see that temperature will decrease slowly but sure. And this will go down. This will go below 100 degrees Celsius. Yeah, if we go at the end of the video. Maybe Zishan, yes, you'll see now it's already under 100 degrees Celsius. Maybe we can skip the video, Zishan? Maybe. Yeah, so sorry for the noise. Not easy to comment that. If we stay 1 minute on this, so the one cell was punctured, and the beauty of immersion cooling is that you can spread the heat of the cell that has been abused on the complete module, because the liquid that is used or the fluid that is used to cool the cells plays the role of doing like a thermal buffer, and the heat is on the complete module instead of being on only one cell. That's why the neighboring cell is not going to thermal runaway, is because the heat is rejected on all the module, and this provide, let's say, an average temperature that is below the 100 degrees Celsius. And this kind of test, we proved many times with partners at EXOS that we can have a pass, which means no thermal runaway propagation, with or without fluid circulating, which is really important. So in that case, the fluid was circulating, but we can also have pass with non-circulation, which means imagine you have an accident with the car and the pump, for whatever reason, is broken or do not work anymore, then still you can have the function of safety thanks to immersion cooling, which is really hard to get and which we can get with very low quantity of fluids, of liquids, which is really important because we don't want, I saw one question was, what is the weight increase with immersion cooling? We can reach between -2% or +2% compared to cold plate. And especially in the case of answering the new GB regulation, the weight needed to ensure that you have no thermal runaway propagation without immersion cooling, which with cold plate is really increasing a lot because you have two cold plates, you have insulation layers, you have paste between the cells, etc. So the answer at the end of the day to get a pass with the new GB regulation with immersion cooling that it could be even with less weight compared to cold plate. All the simulation we've done with OEMs shows that you can have, as mentioned, up to -2%. So it's not a big deal. We won't sell immersion cooling to save weight at the end of the day, but at least it does not add weight to the future standards to cope with new regulations. Okay. So maybe we can move to the next video, for which I have, before we launch the video, sorry, Zishan, just before we launch it, I'd like to give a few words on it. So first of all, I'd like to thank this time our partner Shell, with which we provided this test. Maybe Zishan?
Yeah, I
Can you
think
stop the test?
Yeah, I'm gonna stop it. Just give me a second.
Thanks a lot. Wow. So this was with a cold plate. No worries. So you see, and before we move to the video, thanks, Zishan, you see here that at the top of the slide, you have a cold plate configuration, and you see the test results after the nail penetration with cold plate. You have all the cells that burnt, and it's not only a fire that you have, it's between the fire and an explosion. And you will see in the video that we performed with Shell liquid that with immersion cooling, we have no thermal runaway propagation. So you have soot, that's why it's black, but you see black mass, which comes from the cell that has been abused. But you have only soot and black mass here, but the other cells are completely running after the test, which is a great performance. So now, thank you, Zishan. We can move to the video. It's a 1-minute video. I hope this goes well, and you have no lag through the Teams. This is with cold plate, and you'll see the results. So yes, here you have an explosion, and we're gonna see it through with another camera. So this is naturally with cold plate only, and you will see afterwards the test with immersion cooling. So this is the kind of result we don't want, and now you will see the comparison with immersion cooling. So you see some smoke at the background of the test bench. And you see the temperature rising, and this will decrease really fast. And after the test with cold plate, as mentioned, all the cells have burnt. So there is propagation. The runaway has been propagated. And after immersion cooling, you see only black mass, but the cells that have not been punctured, they're still okay and functioning. Okay, thank you very much. I will give back the speak to Marco for the tests that they performed at Cara.
Yes, this is a different way of initiate thermal runaway. Sorry, Zishan. I think there's a disturbance. Can you hear me?
I can. Just give me a second.
Okay.
Just give me a second, sorry, because it was YouTube, so it was running in the background. I'll just
All right.
share
Okay.
Yeah.
So it wasn't me.
No, it wasn't you. There you
All
go.
right. Okay. So again, so this is a different type of test. In this case, this was performed on modules originally designed to match the characteristic of modules used by Volvo trucks. In this case, with the design modification that this 14 kilowatt hours modules made of cylindrical cells were including two-phase refrigerant to perform heat extraction by phase change. And maybe just as a side comment on that, the two-phase modules designed by Carrar were not heavier, were actually slightly lighter compared to the original ones, which were only using a typically a cold plate. In this case, the thermal runaway was induced by overvoltage triggering, and which, if you do this at even a small cylindrical cell, you can really see fireworks, which is the image below. But when the cell was triggered within the module using two-phase immersion cooling, actually the cell itself didn't exceed temperatures of around 85 degrees C. You can see this in the upper curve, while all the neighboring cells never exceeded 45 degrees C. So the very fast heat extraction, which happens with immersion cooling, using in addition phase change to the gas phase, was introduced a tremendous increase in safety of the system. And I think this is the key message for today. This is the last technical slide on this point. I will give the word now to Zishan. I think it's important now to keep in mind all the advantages. I'm sure there'll be a lot of questions. So maybe Zishan, you follow up with the next section of this presentation.
Yep, sure, we'll do. So thank you, Arno, Cecile, and Marco. We're getting some questions from the audience, but I'll just start by asking a couple of questions, and maybe we can start with you, Marco. So what do you think, how will the new Chinese safety standards influence the choice of battery chemistries in China? For example, the balance between LFPs and high nickel NMC, because we know that Chinese are big on LFPs.
Of course, for sure, this sets a clear standard for battery chemistry to achieve. And of course, in terms of safety, LFP was already the first choice, as mentioned, in the example of BYD Super E platform. But on the other hand, as the standard sets a clear requirements, if the thermal management system or concept is designed to guarantee safety, this is a tremendous opportunity also for NMC to bring the advantages NMCs here, and still combine with more advanced thermal management in particular with immersion cooling, to provide a very safe solution.
All right, thanks, Marco. I have another question, and maybe Arno, you can answer this. So with immersion cooling reducing the TRP risk, could this enable broader adoption of high energy density chemistry batteries, as because previously they were considered a bit volatile? So what's your take on this?
Sure, we still need the entire automotive industry and the other industries needs higher energy dense cells for the future. Because still LFP is not answering all the needs and does not cover all the needs for the end final customers. We should have the dream for everyone is to have a car that costs the same price, upfront price than an ICE thermal car, which has at least the same range and the same charging time. And we are not there yet. So this is what everyone tries to do in the automotive industry. But still, we do believe that the sweet spot should be around 50 to 100% more energy density with the same cost projected than LFP. So if you increase, each time you increase the cell energy density, you have a risk to increase its thermal resistance or a risk regarding the safety. So this is where immersion cooling can cover whatever the cell chemistry and whatever the technology and can brings a lot of added value. So yes, we do believe that immersion cooling will play a role in increasing the density of the energy packs in the future, whatever the industry, but also in the automotive one.
All right, thanks, Arno. I have a question for you, Cecile, as well, since you have been to so many expos. Do you see the European, North American regulators moving in the same direction as China, or do you think China is going to remain unique in this space?
I believe China is leading, so anyway, they are in advance. So we see their standard more difficult than our own standard. But it says that we are going to move because first we cannot stay behind, and also in terms of standard, once you are able to achieve something good, you have to give that to as many people as possible. So I don't know when, I don't know exactly if the standard will be exactly the same or some adaptation, but for sure we are increasing our own standard and we are moving following the Chinese one, at least in Europe.
And if I may add, Cécile, I fully agree. And if I may add, when you are an OEM, now you cannot neglect the Chinese market, which accounts for more than 50% of the world volumes, first of all. And you cannot neglect that the Chinese will come in Europe. They are already in Europe. So you cannot lag behind. And as an OEM, as a European OEM or a US-based OEM, I'm sure you cannot market that your cars are less safe than the Chinese one. This is not something that I feel possible in the future. So yes, they will need to increase the safety regulation as well in the other continents, and they will follow and try to catch up if possible.
Yeah, it seems like Europe is going to move in that direction because they're still pursuing the zero emission policies. North America might be a different scenario, but we'll see how that plays out in the future. So moving on from the market, we have some technical questions here from our audience here. I'll read. So what is the C rate associated with the 300 cycles of fast charge? And I will add one more question here. What is the typical weight increase in including immersion cooling system? So maybe Arno, you can take this question.
Yeah, the last part of the question already answered. It's in the range of -2% plus 2%, depending on the architecture, the fluid, the way it is arranged at the battery pack level. But as mentioned, as safety will increase its requirements, if you have two cold plates, if you have aerogels, if you have insulation layers, if you have the cold plate weight will increase for sure, which makes immersion cooling probably more than competitive compared to new and future cold plates. The first part of the question, which is related to the GB standard, I let it to Cécile or Marco, with which C rate are performed the 300 fast charging cycles on the GB standards, if you know that.
I personally do not know this answer. I have taken a note here and I can check on the standard itself. I don't know the value here. Marco,
Yeah.
if you know.
No, I don't have any number in my head. I think it's probably around at least 3B4C, but or 5C, I would guess, but just a guess.
Yeah,
let's
say we take the answer and we're gonna answer to the attendees afterwards. We'll take the question.
Yeah, we'll send out a follow-up email with the presentation, and if we're not able to answer any questions, we'll follow them in our email. But there's an associated question here. Maybe you can answer that, Marco. So what type of coolants are required for these types of battery cooling systems?
For immersion cooling, there are different fluids, and actually we have several of our GICA members working on different refrigerants. There's as a choice of already existing specialty fluids. That's what they call it. In some cases, it depends, of course, on the type of immersion cooling solution which is used. If it's single phase, some fluids are used. If it's two-phase, of course, specialty fluids are used which evaporate at very low temperatures, typically like 35 degrees C, but is not on top of the development which are ongoing. There are already a range of existing specialty fluids from the major chemistry industries available for all applications.
Yeah, and let's be maybe specific here. In single phase, you have oil-based fluid, so which can be PAO, GTL, whatever kind of oils, and esters as well. And yes, for the two-phase, it can be fluorinated fluids or different kind HFO, HFE kind of fluids that are being used.
All right. I have an interesting question here. So which requirement of GB standard cannot be fulfilled by immersion? Did you already test a pack with new requirements of GB standard in immersion?
Not yet. The expectation, and at least mine, is that immersion cooling solution can satisfy all requirements. It's more a matter of going through the complete validation, which will happen, of course, together with an OEM and a battery maker, as it's a very extensive testing campaign, and we will see that. But in terms of expectation, also based on the tests we've been performing so far, so especially, the key topic or the key requirements now everybody's worried about and want to challenge is the propagation. So prevention of propagation, and on that area, immersion cooling has already shown a fantastic performance. I don't know if you want to add anything on that.
Yes, we can add that this regulation, let's say mobility regulation, is derived from the stationary regulation that is already in place in China. And this stationary regulation also sees some immersion cooling. And now for stationary BESS, so battery energy storage system, we are talking about very, very large batteries, like 3 to 5 megawatt hours in 20-foot containers, and they already pass no thermal runaway propagation with this kind of situation. So I think neither Carrare nor ExoS have or Lightens have been testing full battery pack against the future regulation, but BESS sold in China, some of them are cooled with immersion cooling and already sustain this regulation. So yes, this is feasible. We don't see any blockers with the new regulation for immersion cooling. It could be an advantage, yeah.
Yeah, I see a question here that people often ask, what about the risk of coolant leaking in an impact?
Yeah, I can take this one. So naturally, we put a lot of efforts in all our design for all the industry, all the battery pack makers that are working in immersion cooling. This is a threat. Let's say this is a risk that is directly taken into account in the DFMES. However, it's not a bigger risk than your thermal engines that is running since 2 centuries and carrying 60 liters, 70 liters of gasoline, which can take fire and explode. So
No,
yes, yeah.
I agree. You're right, Norman. Even compared to water glycol-based cooling system, it's much safer because, of course, the immersion cooling solution are not dielectric, do not conduce any electricity. So even in the case of leakage, it's not really risk of short circuit or anything. It's more related, maybe not satisfying the cooling function of the thermal management, which is of course always the case or typically the case when a crash or a destruction of the system can happen. But in any case, it's a development in the safer direction.
Yeah,
I also want to mention that in the regulation 38,031, there are also emphases of no leakage. So there are several tests where you also have to get no leakage.
All right, thank you. Another commonly asked question, any OEMs closest to mass production adoption for immersion cooling? If yes, then which vehicle segment? I can answer some of that is, in North America, Stellantis, GM, Ford, they are all working on immersion cooling technology. Are they close to mass production? Not really, but they are definitely interested. But maybe Cecile, you can add more to this.
Sorry, I was checking the question for the fast charging, so I have not listened to what you said.
Okay, maybe I can take this, Zishan. Yes, AMG, so it's not mass market, it's naturally premium cars, but they are supposed to enter the market end of this year or beginning of next year with quite interesting volumes, like several tens of thousands a year, which is still not mass market, but which will probably explore the frontiers, the limits, the pros, the advantage and drawbacks of this technology for the next phase, which should be a wider and mass market. And it's always like that technologies have been introduced in the automotive industry. It always begin with upper segments like the airbag, the turbo, etc. They were not mass market at the beginning. They were introduced with premium cars, and we do believe that, okay, this will be introduced with premium cars. It's already the case with McLaren, with Koenigsegg, which are not premium, but luxury cars. Next year is going to be more affordable with premium, high-end premium cars still. And we do believe that it will be widely spread if it answers question and get the best cost to benefit ratio for the future regulation and safety and ultra-fast charging. And this is where we see. Yeah.
Sorry. Two things on my side. When I talk to the Chinese in Auto Shanghai, they say that there should be a battery pack with immersion cooling. So I'm not sure it's for hybrid or for a full EV, but they say that there will be a new battery pack with immersion cooling in 2026. So I don't know which OEM and if it will happen, but normally it should get something. And then I have checked for the question about the fast charging, so I can answer to everyone here. So the regulation says that the test must go 20% SOC to 80% SOC with no more time than 50 minutes. So you have to fast charge 20 to 80% in maximum 15 minutes for 300 times, and that's the definition of the fast charging here. It's section 8.8 of this regulation for those who have access to it.
So it will be 4C, right?
Not really 4C because you don't go to 0 to 100%.
Yeah, okay, sure. Yeah, right. A little bit less than 4C.
It's defined like that, 20 to 80% in maximum 15 minutes. That's what the regulations say.
That's perfect. Thanks,
Cecile.
Cecile.
All right, so we're nearing the end of our webinar here. I would just like to share some of our upcoming events. So if you or anyone from your company happen to be in the US during the battery show, we are organizing an event on October 8th, which will be at Huntington Palace. There will be two seminars, one in the morning, which will be from 10 a.m. to 11 a.m., another seminar on thermal management from 2 p.m. to 3 p.m. And for our members, there will be a special meetup with lunch between 12 p.m. and 1 p.m. So if you're interested, we'll send out the email with a registration link. If you're interested, please do RSVP. Other than that, we will be having more webinars in the coming months. There will be a get to know meeting coming up in October. We'll send the details shortly via email. We are also in the process of launching a newsletter, which will be launched somewhere between mid of October. So very exciting stuff coming up. And with that, I would like to thank everybody for joining us today. And as I said, we will follow up via emails and we will provide you more details on our upcoming events. Thank you, everyone.
Bye-bye, everyone.
Bye.
Bye-bye.